Hey everyone, welcome to our first video. So we're going to start by just going over some vocab, but I just also wanted to say hi to everyone and that we miss you. And if you have any questions at any point, just email Miss Holstead and I, and we will get back to you as soon as we can. So we are starting chapter 9, which is sequences and series. 9.1 is where we're going to start today, and it's just based on the patterns that we can find and see and how we can write formulas for them. So the first vocab word right here is sequence. And a sequence is an ordered list of numbers. So the example of 1, 3, 5, 7, 9. So that would be a sequence. And then each number here is called the term. So 1 is the first term, 3 is the second term, 5 is the third term, 7, and so on. Recursive formula is going to be one of the ways we write formulas for the rest of the chapter here. And recursive formula defines the terms in a sequence by relating it to the previous term. So recursive formula is great for finding like the third term, maybe the fourth term, but if you want to find the 100th term, it's not going to be necessarily helpful because you would have to know the 99th term, so the previous term, in order to find that 100th term. And then we have a famous mathematical sequence called the Fibonacci sequence, and it has many applications in art and nature. And the sequence starts here, and we're going to do a couple examples with it later on, so we'll come back to that. And then the other way to write a formula is called the explicit formula, and you can write that formula without using the previous term and just relating it to the nth term. And we'll get some examples of that in a little bit as well. Okay, so now we're going to jump into our examples. And so the first one we have is we're going to be looking at that famous mathematical sequence. And so I've gone ahead and written it out again. So we have 1, 1, 2, 3, 5, 8, 13, and 21. And the first thing we're going to do with anything that we're looking at is find that pattern. So looking at the sequence, what is the pattern? So if we look at it, it's not adding the same thing each time. So if we go from 1 to 1, it's not adding anything. If we go from 1 to 2, we added 1. 2 to 3, we added 1. 3 to 5, we added 2. So that's not the pattern. So then we look a little bit closer. And the pattern for the Fibonacci sequence is actually that it takes the previous two terms and adds them together. So we would add these two, and we get this term. If we add these two, we get this term. Okay, so the pattern is that you are adding the previous two terms. So adding previous two terms. So now we're going to take that information about the pattern and we're going to write a recursive formula. And remember, the recursive formula is written in terms of the previous term. So the recursive formula will always start with a of n, and that's just saying to find the nth term. And to find the nth term, we have to take the previous two terms, so n minus 2, so two terms away, and then add the term right before it. So this right here, the n minus 1, is saying that we're taking the previous term. So if we were looking for the 10th term, this would say take the 9th term, and this would say take the 8th term and add it. And then whenever you write a recursive formula, you also have to show what the first term was, and in this case, since it uses both terms, we need to also know what the second term is. So the first term is 1. This is the first term. And then this one here would be the second term. So we would write it here and here, and that's our recursive formula. So now we're going to look at it and we're going to find the next 3 terms. So to find the next term after this, we're going to go ahead and add 13 and 21. So we have 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th term. So the next term we're looking for is the 9th term. So a of 9. And we do 13 plus 21. And that's going to give us 34. Then to find the next term, we're going to take the 21 and add it to the 34. And that gives us 55. And then the next one, again, we take the 34 and the 55. And we get 89. So these are our next 3 terms right here. Okay, so here's a couple try it problems. What I would recommend is to go ahead and pause it and then try it on your own and then watch what I do to check your answers. Normally, if we were in class, you would work with your partners and then we would have you do it on the board. We're going to explore how to be more creative and more interactive with you guys, so make it more engaging. But for now, just go ahead and pause this video and try the try it problems. So find the pattern first and then write the recursive formula. So go ahead and pause it and then try it. Okay, so the pattern here is that we are adding 3 each time. So our recursive formula is a of n equals, and then the previous term, and plus 3. So really when you're writing a recursive formula, the only thing you need to know is this part right here, the plus 3. This here and this here are always going to be there. And so then we also just have to say a of 1, and then the first term right here is negative 6. So that one's done. Okay, and then we need to look for a pattern here. And this one is a little bit trickier to find the pattern. But if we do 2 times 5, that would give us 10, and then minus 5, and that gives us 5. So then we check it with the next one. 5 times 5 minus 5. Yeah, that would work. So the pattern is times 5, then minus 5. Okay, so again, remember we can just go ahead and put a of n equals a of n minus 1 and a of 1. That's always going to be there when you have your recursive formulas. And then what we add is the pattern. So we take the previous term and times it by 5, and then we subtract 5. And the first term was 2. Okay, again, if you have any questions, I know it's hard because you can't really stop me and ask the questions, but please email any questions you have, and Miss Holstad and I will get right back to you. Okay, so now we're going to work with explicit formulas. So we have a sequence, 1, 4, 9, and 16. So again, this is my first term, second term, third term, and we need to figure out what the pattern is. So if we look at it, it's not adding the same thing, it's not multiplying the same thing. However, if I take my first term and I square it, that would be 1. 2, square it, that would be 4. 3, square it, 9. 4 squared, 16. So our pattern is that we are squaring the term. And so remember, explicit formula, we just write with the nth term. So again, we're still going to have a of n, but then we're just going to take the nth term and we're going to square it. So that's our explicit formula, and we don't have to state what the first term is in this one. It is just that. So then it says find the next 3 terms. So the next term would be the 5th term, so it would be squared, so 25. 6th term, 6 squared, 36. 7th term, 7 squared, 49. Okay. So again, go ahead and pause the video to try doing these ones where you find the pattern and then write the explicit formula and find the next 3 terms. So go ahead and pause it and try it and then check afterwards. Okay, so looking at this one here, we're going to look at what it is doing. Okay, so it's adding 3 each time. So we know that it's going to be somehow replaced in there. However, if I just write n plus 3, that would take this one and it would do 1 plus 3 because it's the first term. So that doesn't work. So we have to write it in the terms a little bit easier, where we have a of n still, and then the pattern is that it's going up by 3 each time. So that's going to go here. So if I do 3 times 1, we would get 3, but I want a 2, so we're going to subtract 1. And that's our explicit formula. And then the next term, so this is 1, 2, 3, 4, 5. So I'm looking for the 6th term, the 7th term, and the 8th term. So 3 times 6 is 18 minus 1, 17, and then you do the same thing, 7 times 3 minus 1, 8 times 3 minus 1, and then there's that one. Okay, and then the last one, we're looking for a pattern again, and if we notice, it's almost the same as our example, except for it's added 1 each time to our example. So this one, we have it's squared, and then adding 1. So we have a of n equals the nth term square it plus 1. And so we need 1, 2, 3, 4, 5. So we need the 6th again, 7th again, and the 8th term. So 6 squared, 36, plus 1, 37. 7 squared, 49, plus 1, 50. And the last one, 8 squared, 64, plus 1, 65. Okay, so again, if you have any questions, email Ms. Holstead and I. But we'll also do a live video and answer questions if the emails don't help when we respond back. I hope you guys are all doing well and staying safe, and I hope this video was helpful, and have a good day.